The last time, well, day before yesterday, I realized I got a bit ahead of myself, as I usually do. It's a good thing. And what did I do? Yeah, I tried to compensate for the problem with variables and looking up variable values, I think, without using a symbol table. Yeah, if that makes sense. I don't know if it makes sense. It doesn't make any sense to me. But I know what I did. Anywho, we gotta redo or do better some of the things. That's it. Yep. Okay. Sounds good enough to me. Okay, the symbol table. What is this all about? A symbol table is a data structure used by a language translator, such as a compiler or interpreter, where each identifier, symbol, constant, procedure, and function in programs source code is associated with information related to its declaration or appearance in the source. Okay. So it can be used with functions too. Interesting. Now that does make more sense. The symbol table, as opposed to whatever I did. What did I do? Instructions, constants. Oh yeah. I just made a slice of a slice. Oh yeah, okay. I just look up an array. I mean, it's kind of a symbol table. It's not much of a table, but I like it. It's fast. Performance is key. Is what I'm telling myself. Right, okay. Can be used in every phase, from lexing to code generation, to store and retrieve information about a given identifier. Something's wrong with my light. Information such as, yeah, that's something my implementation is missing. But right now, I don't know the scope of a variable. Or the location. I know the location because I can retrieve it. Yeah, okay. Whether it was previously declared, yeah, I can know that. Which type the associated value is, and anything else that seems useful while interpreting or compiling. We're going to use the symbol table to associate identifiers with a scope and unique number. Okay. For now, it should do two things. Ah, okay. Identifiers in the global scope with a unique number. I mean, my implementation kind of does it. No, actually it does it. But yeah, the scope is still unknown. Get the previously associated number for a given identifier. Definitely can't do that. Why do we need that? Previously associated number. Define and resolve. Define an identifier in a given scope to associate some information with it. Later you resolve the identifier to this information. Okay, I'm listening. The information itself we'll call the symbol. An identifier associated with the symbol, and the symbol itself is what contains information. Okay. I mean, okay, the variable and its value, it's the symbol. I'm gonna read that again. Common names for these two methods on a symbol table are define and resolve. You define an identifier in a given scope to associate some information with it. Later you resolve the identifier to this information. Okay. Okay, that's the lookup part of it, I guess. Yeah. Okay. Okay, got it. It's like an So it's like a variable for a variable. Working code helps to explain this. Here are the type definitions that make up the symbol table. Make up our symbol table. It's part of the compiler. Symbol scope. I see. Because functions can also be in the lookup table. So you'd use the name of the function look up the scope. Okay. And the symbol is name, scope, and index. I'm guessing he's created a type to create a method on it. Index, so it is basically stored in an array. Why a map? Num definitions. Symbol table has a store and okay, current number of symbols. Yeah, okay. I could just modify my global symbol table. Let me zoom in. How's that? Maybe a bit more. Okay. Yeah. I mean, right now it's global. But if I modify this slightly, I could make it work. I don't see the point of using a map. An array should be fine. Plus, I mean, it's mostly because standard. I'm a bit lazy to see how hash maps work in Zig. I think it's pretty easy though. Doesn't seem too bad. Can use a hash map. Not a problem. Okay, and then you return a new symbol table. Okay. The first definition here is that of symbol scope. Type alias for string. The value of a symbol scope itself is not important. What's important is that it's unique, because we need to differentiate between different scopes. We use strings as the aliased type as opposed to an integer for a better debugging experience. We then define our first scope. In the coming chapters, we'll add more. The next definition is that of symbol. I mean, okay, this is just blah 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 blah. Okay. Maybe I'll read the last bit. The names and types. If you haven't used the symbol table before, but why not? We build in a map. Yep. There is no hidden wisdom. Excuse me. Water. What does define do? Okay, it doesn't exist yet. Also, where's this index coming from? Is it just the key in the map? Hmm. Does it not need... Okay, if you don't pass the scope, I'm guessing it's global. Oh, it says global here. Aha, I see. Okay, I see how this works now. So would that mean if when we are within a block or a function, it would create a new symbol table. Let me have a look at the AST function literal. block statement. So in theory, instead of having when I compile block statements, is there a way to identify? Yeah, that is actually. What I could do is pass in scope, which would be it is simpler, but it's also complex. I mean, it makes the compile a bit more complex. We would have a scope. Yeah, either case, either way, you need something more than a string, I guess. Okay. Okay, let's just test. Test define, blah blah. Note that we don't have to say in which scope we want to create the definition. It's the job of the symbol table to track that for us. We only call define A, and the symbol table associates the identifier A with a new symbol that contains the name. What if A has already been defined? Well, we throw an error. The scope and the symbol that contains the name, the scope, and the index. The index is the Unix number thereafter. In test resolve global, we do the reverse. Okay. We had the symbol table and identifier that was previously defined and expect it to return the associated symbol. Again, the only argument is the identifier. Is it because both these tests are assumed to be global scope? Not sure how the whole scope thing is gonna work. Associated symbol, again, the only argument is the identifier. Resolve A. What? Okay. Guess resolve A returns an object. Excuse me. Define A. Interesting. How did I get the value back? Global. Ah, okay. Because I've... No. Okay. Identifier. Just realized. How was I planning on getting the object? Set global. Yeah, because all I was keeping track if was the variable name. Huh. I missed. I didn't really think it through, did I? There's quite a few holes in my implementation. Yep. Or maybe it would be up to the compiler. Sorry, the virtual machine. To resolve it from... Yeah, no. That was not gonna work. Okay. Um. S dot num definitions. Okay, it's just incrementing the number of definitions. Scope is global scope. Right. Okay. And dissolve is just get the value from the map. Okay. Num definitions. Okay, it's just an integer. Yeah, but I wouldn't know. Up get global. Using symbols in the compiler. Yeah, when you come across a let statement, I mean, it's quite similar to what I'm doing with an array. So far, except the scope, I'm doing pretty much the same thing. Yep, and then now you set index as an operand. Yeah, that's what I do too. What's failing now is the test that makes sure resolving a global binding works. Instead of defining an identifier and emitting an opsec global instruction, we now have to do the opposite. Opget. Symbol table whether the identifier was previously used as part of a let statement. Yep. At the symbol table. Yep, I think I've already done all of this. If now we return an error, looks like other map accessing Go, doesn't it? But I want you to note that is compile time error. Way ahead of you. Already done that too. Hey, I'm kind of a natural when it comes to compilers. While executing, what I'm realizing is I knew way more than I thought I did. I just had to test it. While executing the monkey program now, we can throw an error. Yep. Get global instruction. See, this is the part that I don't get. I've done the same. Can't remember how I was planning on resolving the value in the virtual machine. Excuse me. All of this is fine. The operand matches the one used in offset global instruction. The index associated with the symbol. A symbol table took care of that. Yeah, this is the part that I want to know. Because I can modify my implementation later if needed. Because as of now, the only thing it's missing is scope. Which is a problem for later, really. Does this work? Take test source compiler. Okay. I'm guessing I added a test. Okay. Yeah. I think the execution bit was what I wasn't sure of. I can turn this into a symbol table. Let's make it destructive. Const symbol table. Would have scope. Not sure what that would be. And then variables. Could We could still just be a const u8. I mean, there's one way. Scope dot would be use 64 and scope and what I was thinking was when I come across a block statement, nah, that's gonna be a pain in the ass. Say 0 is global. Okay, I think I'm getting ahead of myself. Could have add symbol. What type symbol? Okay, never mind. And then get symbol. I think this would take I think that'd be the only modification so far. And as of right now, I don't need to do this. I can do this later. Date existing global variable to symbol table. Unless we can get scope info from existing implementation. Yep. Let's have a look at execution. That's what I wanted to see. Really? And also these opcodes. That just says to me that you don't need anything more than an array. It depends how scoped symbols are handled. Problem for later. Making them pass, blah blah. Okay, I do like this. How could this work? Let me have a look. Offset global. So the statement would be something like x equals 5. And then the opcode for this would be offset global and then index. Index. He says it's easy, but I found this part easier. This bit I don't get at all. VM doesn't know, blah, 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 blah. We need a place to store. Okay, that makes sense. Since the operand of both opcodes is 16 bits wide, we have the upper limit on the number of global bindings our VM can support. That's good because a limit allows us to pre-allocate all the memory we will use. Okay. We use slice because it gives us index based. Ah. I guess you'll use the index of offset global to store. Okay. How do we get the value? How do we get the object? Let me check the compiler again. Okay, there we go. I think we gotta pop the value of the op constant. Because if this x wasn't here, I mean, there'd still be a pop at the end. This new global field of VM is the global store. We use a slice as the underlying data structure because it gives us direct index-based access to single elements without any overhead. Okay. Gotcha. And then you can use the same index to get it back when you come across opget. Is that it? Yeah. Get the index and then what? VM push. Gotcha. Okay, that makes sense. I guess this can't be undefined because otherwise it would have been a compiler error. Okay, cool. VM dub push. What the fuck is... Okay, push it back onto the stack. That's it? No way. That is crazy. That was way easier than I thought it'd be. But I still don't know how it works. I think all we're doing is taking it off the stack. No, sorry. Is it? Yeah, we are taking it off the stack and putting it back in when it's needed. That kind of makes sense, really. Okay. What do we need? Globals. It's an array of... Is that a U16 max or something? Takes 2 or more arguments. Oh, okay. Just returns the max of 2. Okay, that's fine. P6, 5, 3, 5, 6. Is that it? How big? 6, 5, 5, 3, 6. Object dot object. Okay, up get set up set global. What do we need? It's very similar to actually up jump. Identifier index. and then self dot globals of identifier index equals self dot up. Okay, and then get is do the same. Self dot push self dot globals of identifier index. Okay, apparently that's all you need. Yeah, I can add it here. We'll add the same test. Then expected 3. Test source virtual machine. The only thing I can think of is that the array goes out of scope and the value is no longer available. Okay. New. Where? Okay, yeah. This is something I'm not sure how to do in Zig yet. That is, how do you declare an empty array? To this, I could make it all null. Okay, you can just make it undefined. Why can't I get... Oh, fuck. I'm on the wrong file. Okay. Where constant index is less than self dot constants dot len. Which line was it? 52. Hmm. I gotta make the stack bigger. 6 5 5 3 6. Might have to remove that assertion. That is no longer true. Let me. Oh, jeez. Ah, I know. Fuck. I know why it's happening. I made a mistake. Object global index instruction index plus equals 2. Because I've just read 2 instructions. Yep, that makes sense. Guess that's one of the problems. Integer cast truncated bits. Oh, I know why it's happening. No, I don't. New instructions. Where is it coming from? Compiler. Hmm, this is weird. Did I update? Zig test source code.zig. Okay, that's fine. Compiler. Source 128. Have I defined width? Offset global. Get global. Yep, they have the right width. Integer cast truncated bits. What's that mean? Is it because... Hang on. I think I might know why. Yep, because self-taught instructions. No, but no, that's not it. This is new. What does this mean, really? Integer cast truncated bits. Let me ask Cloud. What is the error? Teacher cast truncated bits mean? This error occurs when you're trying to convert a number from a larger integer type to a smaller one. Interesting. Where am I doing that? Cast converts an integer to another integer while keeping the same numeric value. The return type is the inferred result type. Aha, okay. The weird thing is, how come it never... It never added until now. Yeah, that does make sense. Attempting to convert a number which is out of range of the destination type results in type-checked illegal behavior. Okay. Use truncate. But it... Okay, I think I know why. Because I'm trying to make a number that's bigger than 16 bits. Maybe, is it? Yeah. Let me read that again. Attempting to convert a number which is out of range of the destination type. Yeah, it should never be out of range, because all numbers are 16 bits. So if I right shift it 8 times, is that where? Yep. Let me check my test. What am I adding? Okay, I think I know why. I don't think it's... I know why it's happening. Because fucking globals is some insane number. Okay. Standard. Can I predefine the size? When using standard dot array list, can I predefine the size of the underlying array? I can go make type size. Ensure total capacity. If current capacity is less than new capacity, invalidates element pointers if additional memory is needed. Ensure total capacity precise. If the current capacity is less than new capacity, this function will modify the array so that it can exactly hold the new capacity items. Okay. Guess that could work. I mean, if you're wondering what the problem is because once the virtual machine... But hang on, why? I mean, that's the only thing I can think of, really. That a slice, and then here of object dot object not init allocator. Actually, before I do that, I want to try one more thing. What was it that I wanted to try? Add a underscore object dot object of dot null times 65536. No, there should be no. I'd like to print that value, see what it is. Why here? Ah, for fuck's sakes, I know why. It's none of these. I just realized the problem. Stack size. Yep, because the null value is greater than okay, now I get it. Fuck, I should have just read the error. Jump not true. Should be stack size. Yep. I think it's in the compiler. Stack size. I think that's the biggest number it can take. Okay, I think that might be too big too. Is it an unsigned? Okay. -1 makes it better. At least I'll understand. Remember why. Zig test vm.zig source vm. Okay. will lead to needs to be max stack, sorry, max 16-bit number. In Zig, is there a way to get the max 16-bit number like in Swift? Was it uint 16 stop max, something like that? Okay, I think that makes, I'll add that. Should be fine. Yep. Then whatever I need to find 65 65536. Stack size. Okay. Damn, that was a bit of a round trip. I still don't have a symbol table, but the important thing is that at least global ones work. Just gonna separate these. Machine let statements. Two is I want to check if that works as well. Okay, does. Global variables. Oh, that's fine. Okay, what will be next? Yeah, I don't have a store either. Oh, I should try the repo. Yeah, because it goes out of scope. Yep, we're on a new virtual machine. All we need are new constructor functions for a compiler and virtual machine that allows us to keep global state in the repo. Okay, passing the old symbol table and constants. I'm not sure if I can do that because I because yeah, this might be harder than it is in Go because we go to the repo. Oh, actually, it might be easier. Yeah, it's fine. The memory is still here. It'll get cleaned up at the end, which is fine. Is it new compiler or virtual machine or both? Okay, it's just the compiler. Oh, and the virtual machine. But do we need... yeah, because... we don't have the old instructions, so we need to... okay, that makes sense. Okay, I don't know if I'm too inclined to do this now. I might as well do it. Otherwise, I will not remember. Function unit state, take an allocator, and then constants. constants, a slice of object, and then global variables. Slice of const u8 would return compiler. Yep. Is new allocator. C dot constants is constants, and C dot global variables is global. Turn C. And then do the same for virtual machine pub on new with state would take locator, then constants, and then globals. Good. Return virtual machine. So new allocator vm dot constants is equal to constants dot globals return vm. yeah, var VM is equal to try VM dot new allocator. How would that work? I guess empty bytecode. The bytecode. Yep. With state. What did it need? Constants and globals. C dot. Don't know if I can access this. Dot global variables. How do you mark these as public? Are they already public? I'm not sure. Yep. Did I not change these already? Oh no, I forgot. Virtual machine is okay. New with state allocator. VM virtual machine dot constants, and then virtual machine dot global. Was it globals? What was it defined as? Yeah. Take build run. Really? Okay, that's weird. Allocator should have been first. Never mind. The way repo. Okay, I mean, it is optional. New with state. Yep. Is it compiler? Yeah. New with state. This is optional. This too is optional. New with state c dot global variables. Var, is that it? Add a little requires address of operator to cover slice type. What's the difference between aren't they both slices? Okay, I think globals. Oh, it's an array. Well, to be fair, it is an array. It's not optional. Why did I make it optional? I don't know. Weird. This is stack size. Okay. Let x equals 1. Fuck. That is brilliant. That's funny. Constant x is less than constant x is less than constant dot len. Think I know why it's happening. It's because no, I don't know why it's happening. Virtual machine 52. Standard debug print. Constants.len. Okay, let's see what's happening. Let x equals 1. They're both 0. I mean, it seems reasonable, right? Ah, I know why. I mean, less than or equal to. It's also fine, I guess. I guess not. I must have added it there for a reason. Okay. Hmm. What was the problem? Index out of bounds. Index 0, len 0. Self-dub push. Okay, that's weird. Yeah, there should be at least one item on the stack. That is strange. Yeah. That is so weird. Why is the index 0 when there's nothing in the stack? Nothing in the constants. Okay, so I think I need VS Code. Repo. I do want to check something first. So when I do this new with state business, I should have made it. I think I can make this nullable. Yeah, I think that's probably better. Hang on. What is b dot constants? Here. Okay. Constant. Index out of bounds. To be fair, oh yeah. I think Apple Virtual Machine. I think this might be the problem. It should be compiler. Yeah. Yeah, what the fuck am I doing? Yeah. I think I need to pass the stack and globals. Not the constant. Yep. What's the stack? Stack size. Okay. Small mistake. And then in the repo, it should be virtual machine dot stack. Okay, and then let y equals 2. What the fuck, you ran out of memory. Oh, I knew. I was hoping this would be fine, but it's not. Because I'm allocating stack size worth of memory every time. Hey, at least I know the error works. You know what? This is a problem for future me. Do fix out of memory error. Got to do like some sort of cleanup. Yeah. That's gonna have to wait. I wonder how Go does it. I mean, I'm gonna have to fix it soon enough. Because I can't. I mean, it's only a problem in the REPL, really. Who really uses the REPL that much anyways? I don't. I can just not have a REPL. But that is an interesting problem. What if I do let x equals 1, let y equals 2, x plus y. Yeah, that works. The only problem is if I do equals 4, x plus y plus z. Boom, run out of memory. I mean, it might also be because I'm using what do I use the allocator for? Oops. Compiler new I don't know if this is like a very efficient way of doing it. Because I create a new array list every time. I could ensure precise length. Maybe. Okay. That to do. Keep new array list capacity only as many as needed. It'd be ideal if I could do it before I initialize the array list. Okay. Never mind. I think that's good enough for today. REPL, not repling. Okay, I think that's gonna call it today there. And we move on to string array and hash. There's only a problem with the REPL. I just pretend like I don't need a REPL. We'll see. Okay. I guess that's it for today. Hope you have a good weekend. And I shall see you back here tomorrow.